like many programming languages, Python knows about some basic types from the start. Some types that you can use right away and you don't need to define them. So in the case of Python, those types would be integers, floats, booleans, lists, dicts, strings. There are many of them. So we'll see a few in this lesson so you can actually get started working with Python. On the right, I have started my shell, and on the left, I have some code to actually run. So let's see the first case, the booleans. So the booleans is actually quite simple. The booleans can be true or false, so I can ask Python to print true or false, and this is the first two lines. From the third line, I start evaluating expressions involving those booleans. So true and false, I use the operator AND to combine two booleans to form a new one, and true and false, that outputs false. True or false, that outputs true. Okay, so this is for basic operations on booleans, and here are a few more examples. You can assign the values 6 to A and 7 to B, so those are obviously not booleans, but you can start making expressions from A and B that are actually booleans. So is A equals to 6, for instance, that would be true. Is A less or equal to 7, that would be true. Is A different from B, that would be true, and so on. So you can pretty much evaluate all of those except this one that involves two different operators, not an AND. So if you look at this and try to think about what will happen, so here we have A equals 7, which is clearly false because A is equal to 6, and B equals 7, which is clearly true because B equals 7. So we have not, false, and true. The problem is we're missing some brackets. You have two different ways of bracketing this expression. You can either do not open bracket this whole thing, close bracket. That's one way of doing things. Or you can do open bracket, not A equals 7, close bracket, and B equals 7. Those are two different ways, and they will return different outputs, different values. Okay, so which way is used? Well, you can infer it from the fact that in this case we have returned true. But let's look at lines 9 and 10. So lines 9 and 10 are exactly the same thing, except that some brackets are present in 9 and some brackets are absent in 10. So if those two return different values, we know that the bracketing that is used in 10 is not the bracketing that's used in 9. And that's indeed the case. In 9, it's returning true. In 10, it's returning false. So we can't be using the bracketing from 9 in 10. We have to use a different one. So let's see that. Let's print an 11th line that is using the different bracketing. Do we get the same as on line 10? Yes, that's the case. We get the same. We get false in both cases. So if Python is not given instructions on how to bracket not and AND, the conclusion we must draw is that it's using this bracketing that gives precedence to not over AND. Okay, so that was a bit subtle, and it's definitely a source of a lot of errors if you start manipulating booleans. Now we'll look at a different thing, which is the conversion between types. As soon as you have more than one type, you have the problem of how you convert the value from one type to another. Is that even possible? If you have an int, you want to be able to convert it to a float. Okay, well, Python allows you to do that, but it allows you to do a lot more, which is maybe a bit surprising at first. So let's look in particular to the conversions to Boolean. So if you just type bool and an empty bracket, you're not actually doing a conversion. You are creating a new bool, and by default, that bool would be false. So let's look at the actual conversions. Here we're entering the integer 0 and converting that to bool, and we get false. If we're entering the integer 3 and converting to bool, we get true. If we're entering the string a word and converting to bool, we get true. If we're entering the list 0, 1, 2 and converting to bool, we get true. The empty list converting to bool, we get false. The list with 0, 0, 0, we get true. And the empty string, we get false. Okay, so maybe this is a bit difficult. It's a bit difficult to figure out the logic behind all this, but there is a logic, and I'll tell you now what it is. If you try to convert nothing, none, to bool, you get false. And similarly, if you try to convert something empty for its type to bool, you'll get false. Otherwise, you get true. So most of the time you get true, actually, except when you give in something that is close to, in meaning to empty. Okay, so what does that mean, close in meaning to empty? Well, for maybe it's a stretch, but for ints, that would be 0. So if you convert 0 to bool, you get false. For a list, like here, if you convert that to bool, you get false. For a string, like here, if you take an empty string and convert it to bool, you get false. In all the other cases, including this one, maybe a bit surprising, where you have a list of zeros, and you convert it to bool, in all those other cases, you get true. Okay, so this is definitely a bit different from what you're used to, but it can be very useful. So we'll see that now. So in order to be able to see that, we need to define a new variable, which is x, and we assign to it the value of a string, some words. Okay, and then we decide to print 1 and whether x is equal to some. So there is nothing fancy going on here. We just have a string some words and compare it to the string some, and we get the answer false. We can similarly compare x to some words, and we get true. I should have said, actually, this is a comparison operator with 2 equal signs, and I've already used it before here, and it's different from the assignment with just 1 equal sign. So I forgot to say that. Okay, so here in this case we're comparing strings and whether x is equal to some words, and it's true because x was assigned the value of some words. Okay, so we can start doing some more crazy stuff with the strings and the booleans and how they interact, and this is what we'll see now. It's called short-circuiting. So let's say we print the expression string A or string B. So what does Python do with this? Well, Python takes in this part and figures out that in the middle there is an operator. And this operator is expecting booleans. So it will start from the operator and look at the 2 expressions on the left and on the right. And in this case, it's 2 strings, the string A and the string B. And it will try to convert it to boolean. Okay, so it will try to convert first the string A to boolean. Now that's not an empty string. So if you convert this to booleans, you get true. Now Python looks back and it has an operator OR, and it wants to do true or whatever this evaluates to. But it can already stop there because it knows that this is an OR operator, and if it has a true on the left, well, that's it, you're done. It will be true. The outcome of it will be true. Except that this expression's value is not true. This expression's value is the value of the first expression, the one on the left. So in other words, OR is used in a maybe slightly different fashion than you would expect. OR returns the first value if it converts to true. Otherwise, it returns the second value. Okay, so let's see this in action for the 4th line. So now we're doing the empty string or C. Now the empty string, when converted to bool, gives false. And we're doing false or whatever this converts to, and false or means, well, it's not decided yet. We have to look at what the other side converts to. And this is a non-empty string, so this will convert to true. Okay, so in that case, because the first expression converts to false and the second expression converts to true, then it should return the second expression. And that's indeed what it does. Python has just printed C. Okay, so the student who is very much paying attention now should ask, but what happens if both convert to false? Okay, so what if we have an empty string or an empty string, which is both would convert to false? Well, in this case, the outcome is an empty string. And this is what has been printed here, and you don't see it, right? So if you have something that is false, that converts to false, or something that converts to false, and you do an OR between the two, well, it will return that something. Okay, now you can also use AND for this. So if I have something that is empty and something that is empty, both of those, when converted, will give me false, and the outcome will be either of the two, which is the empty string. Okay, so the next line, we use this short circuiting to do something interesting. So here, some words or other words, well, that can be evaluated directly. Because the first one will convert to true, the outcome here will be some words. And then I'm testing equality with x, which was assigned some words, and so I get true. Okay, all this is a bit complicated and a bit unnecessary if you want, but we can go back now to simpler Boolean expressions. So, for instance, we can see whether x is equal to other words or whether x is equal to some words and return the outcome. So x is not equal to other words, so this gives false, while this will give here true. And we have false or true, so we have true. And so Python will return the value here, which is true. And similarly, we can combine this with not. Okay, so this is strings and booleans, and the next big type is integers. So let's see that. So let's assign 10, the value 10 to A, the value 23 to B, and let's print 1 and the type of A. So type is a Python function that will return the type of the object you put in. So in this case, Python tells you, I know A is of type int. Same thing for B, I know B is of type int. Now you can also ask for Python to do the addition, the sum of the two, so that would be 33, the difference 13, the difference the other way around, so that would be minus 13, and change sign of A. So you can take the negative of an integer. All this is very usual and not surprising. Maybe a bit more surprising is the division. So if you do the division of 10 by 23, according to Python, you get 0. And if you divide 23 by 10, you should get 2. So this is meant to always give you an integer, to always output an integer, and this is the integral part of the result of the quotient. Okay, so 23 will fit 0 times in 10, while 10 will fit 2 times in 23. That's the question that Python is answering there. Now you can also use the calculate the remainder, and this is done with a percentage sign. So here I have 23 remainder mod 10, and this is 3. You can do the absolute value of something like the difference. Here a minus b is minus 13, and then I take the absolute value. You can take the power, so this is 2 to the power 3, or you can take it explicitly in this way, power, and of course the 2 give you the same thing. Okay, so this was for integers, and now on to floats. So for floats, you enter them with a dot. So here I assign 66.6 to C and 30.25 to D. I assign some value of pi, and you see that Python knows all of those immediately are floats. So you could ask me, okay, but if I type A equals, so it's a bad idea to assign A. If I ask x equal 5 or y equals 7.2 or 7.3, then Python knows that the type of x is an int and the type of y is a float. Now, how would I ever assign a float of value 5? There doesn't seem to be a way, right? Because as soon as I enter 5, Python thinks it's an integer. Well, there is. You can also assign 5 dot, and this will be interpreted by Python to mean the float 5. Okay, so this is for basic assignments with floats. You can do some things with the floats. You can convert them. So if you remember, C was 66.6, so I can ask to print that as a converted integer. So I'll convert here from C to an int and ask to print it, and I get 66. Okay, so this is rounded down to an integer. It's a very nasty operation for a mathematician, I guess. The next thing you can do, so A had value 10, you can also convert it to a float. So this is done here. And once this is done, then the outcome would be 10.0, indicating that this is a float. You can divide the float value of A by the float value of B. So A started as 10, B started as 23. So here you're taking, in other words, you're taking 10 dot divided by 23 dot. You're considering both of those as floats, and this is the outcome. It will be a bit different if you print it. That's another difference. It's shortened by Python. It thinks if you want to print it, it's for graphical output, so it needs to print less digits because otherwise you get swamped with the size of numbers. Okay, so just a reminder, oops, what happened here? Just a reminder, the value here of C was 66.6, the value of D was 30.25. So now I want to do this. I want to do division like I just showed you. So C divided by D would be 2.2. But I can also do more integral style division. So how many times does D fit in C? This is with the double slash. So now the outcome is a float, but it's the float conversion of an int, essentially. And there is also the function divmod for C and D floats that will return precisely this integral quotient and then the remainder. So if you do 2 times D plus 6 point essentially 1, you should get 66.6, which was the value of C. Okay, essentially because floats are just approximations, so you have to be careful. The 6.1 is actually saved in memory by Python as 6.099, so be careful with that. So to illustrate this, let's see what happens if I print 0.1 plus 0.2. I get 0.3, but in memory actually this will be slightly different. It will be 0.299999 and something. And if you remember what I said earlier, that Python tries to print less digits for strings, for floats, less digits than it actually knows, well, then it will try to print less digits and it will round the number that it holds in memory, which is close to 0.3, but it will round it to a certain number of digits. And this is what happens. This is the rounding result. And so here is an explicit call to round. So I can round 2.675 two digits, two significant digits, and this would 2 digits beyond the comma, sorry, and this would be 2.67. Okay, so those are ints and floats and strings and bools, but sometimes you have very long ints. So what's the difference between a very long int and an int? Well, Python thinks that ints should be of relatively small size. So there is a bound that's sometimes dependent on your machine on the size of the ints, but then it also allows for very long ints, arbitrarily long ones, and this would be here an example. So you just, and it will automatically realize that this is a long actually, and print, if you print the type of very long, you get indeed long. And you can also do a conversion from an integer to long. So here I would convert the integer 34 to long and I get 34L. The L is just meant for display to indicate to you that this is a long. And also you can decide to enter some very large numbers with floating point arithmetic. So we'll see this later, but here it means 10 to the 53. And you can see that this is understood as a float. Okay, so once you have this, you can do conversions between those types. So this is indicated here. You can convert the mass of the universe that I just entered, 10 to the 53, to a long, and you get this. So normally you should get 1 followed by 53 zeros, except that this 10 to the 53 didn't exactly fit in memory. It doesn't quite fit the way the binary encoding that Python is using for floating points. So actually what was saved in memory was slightly different from 10 to the 53. And then when you convert it to long, you actually see the error that was made in this approximation. So we'll see this later. Now, on the other hand, for very long, there was no approximation. So you can also look at big powers or big numbers that are obtained by taking powers. So 234 to the 15, compute the big power of that, and the type is definitely a long. It's an integer, so Python knows about this, and it will print the full expansion of that integer or that long. And you can also convert it to float, and here another approximation is made. So Python looks at the size of this number approximately, and it's on the order of 3 times 10 to the 35, and it figures it should keep some number of digits, which it does here, but it doesn't keep the rest. So if I take this and convert it back to long, I will not get the exact same thing. I will get something similar up until here, but then it will stop, right? So you see this is the same, but the rest is just lost because of approximations. So now you have seen some basic types in Python and how you can do basic operations with them, operations within a type, and then conversion operations as well.